glad you're here. I'd like to take you on a special journey into my science. If you're wondering what a pond has to do with science, let's take a closer look, because you can learn a lot from nature. At the edge of our pond, you can see water lilies with their water-repellent leaves floating on the surface of the water. Small insects, so-called water striders, can also move on the water surface. Have you ever wondered why they can do this? Let's dive into this unknown world like a real scientist would. Let's use a change of perspective to think about it. Our little water strider is sitting up there again. Come on, let's take a closer look at him. The secret of why he doesn't sink into the water must have something to do with his legs when they touch the water. Let's zoom in on the surface of the legs. In science, we use a scanning electron microscope to view in detail from the micro to the nanoscale. That's exciting, isn't it? As you can see, the water strider has many small, fine hairs on his legs, which we can't see at all with the naked eye. And because the water strider regularly lubricates these hairs with body fat, they are water repellent or hydrophobic, so water can hardly penetrate into the spaces between the hairs. At this point, we shouldn't only talk about the water strider, but also about the properties of water. I'll explain these to you by taking a trip to one of our laboratories at Kiel University. Chemically speaking, water is made up of water molecules, H2O, as you've probably heard before. There is a bond between the hydrogen and oxygen atoms of two water molecules. This is called the hydrogen bond, and this is what creates the surface tension of water. If we now drop a ball into a container with water, the ball will break through the water surface. In other words, the water molecules will be pushed apart, thus breaking many hydrogen bonds. The weight symbolizes the weight of the ball, and the spring stands for the counterforce created by the surface tension of the water. Now we're at the Faculty of Engineering. This is where all this knowledge about the phenomena of nature is used for cool research in material science. In a furnace, zinc oxide is produced by a reaction of a special mixture of substances at over 600 degrees Celsius. Let's take a closer look at this. During the reaction, zinc in gas form is released and reacts with oxygen. This produces forearm-shaped, tetrapod-shaped zinc oxide structures. After some time, branched networks are formed from the individual structures, which in this state, however, are still water attracting, so hydrophilic. Water is absorbed into this structure rather like into a sponge. If the tetrapod zinc oxide is then coated with gallium nitride, it changes its surface property from hydrophilic to hydrophobic. We now have a microstructure that doesn't absorb water and therefore will not sink into the water, just like our water strider's leg.